everyone, this is Payavala Bhavagna from Institute of Aeronautical Engineering IARE. Today I am here to explain my topic from the course Differential Equations and Vector Calculus for AAT-2 concept video, and the title is Vector or Cross Product with Examples. I am from Computer Science and Engineering section A and my roll number is 24951A0559. Now let us get into the topic. Introduction to vector product. The vector product, also known as the cross product, is a mathematical operation on two vectors. It produces a third vector that is perpendicular to the plane formed by the two input vectors. The cross product is denoted as A cross B, where A and B are the vectors being multiplied. Now let us know about the mathematical definition. The cross product of two vectors A and B is defined by the formula mod A mod B sin theta, where theta is the angle between them. The result of this operation is a vector, not a scalar. When two vectors are being multiplied, the result will be a vector and not a scalar. The magnitude of the resulting vector represents the area of the parallelogram formed by A and B. Direction of resultant vectors. The direction of the resultant vector follows the right hand rule. If you curl the fingers of your right hand from vector A to vector B, your thumb points to the direction A cross B, that is this side, and the vector would be like this. This property is crucial for applications in physics and engineering, including maths, and in most of the calculations which include vector, this plays a crucial role in calculations. Now let us know few properties of cross product. The cross product is anti-commutative, meaning A cross B is equal to minus of B cross A. It is a distributive over vector addition, so A cross B plus C equals to A cross B plus A cross C. This cross product of a vector with itself is 0. That is, when you multiply, when you do the cross product of the same vector, which example V into V, which it gives you a result as 0. Here in the example that we have on screen, we took it as A cross A, that is 0. Examples of cross product calculations. Consider vectors A equals to 2, 3, 4 and B equals to 5, 6, 7. The cross product A cross B can be calculated using the determination of a matrix. The result is the vector A cross B equal to minus 3, 6 and minus 3. You need to do this in the form using the determinant of the matrix, where you take a matrix and you give the these inputs in there and you get a value as minus 3, 6 or minus 3, or you can totally do it in the scientific calculator, which is easier to implement in exam. Now let's know about the geometric interpretation. The magnitude of the cross product relates to the sine of an angle between two vectors. This geometric interpretation allows for visualizing the relationship between vectors. It helps understand concepts like torque and angular moment in physics. Application in Python. Applications in physics. Torque. Torque is defined as the cross product of the position vector and the force vector. Mathematically, it is represented as T equals to R into F, where torque is torque, R is the position vector and F is the force vector. Torque determines the rational rotational effect of a force applied at distance from a pivot point. Applications in physics. Angular momentum. Now we are looking at few of the applications of this cross product in physics. Angular momentum is also a cross product defined as L equal to R into P, where P is momentum, L is angular momentum and P is linear momentum. This product captures the rotational motion of an object around a point. It plays a critical role in understanding conservation laws in physics. Cross product in 2D versus 3D. The cross product is primarily defined in three-dimensional space. In 2D, the cross product can be extended by considering the vectors. In 3D, context with z coordination of 0. The result will still yield a vector perpendicular to the xy plane with a non-zero z component. Examples of cross product in 3D. Now let us look at few examples of cross product in 2D two-dimensional. For vectors a equal to 2, 3, 0 and b equals to 4, 1, 0, the cross product a cross b equals to 0, 0, minus 10. This indicates the magnitude and direction of the resultant vector in the z-axis direction. The outcome illustrates how 2D vectors can still exhibit 3D properties. Cross product and area calculation. The area of parallelogram formed by two vectors can be found using the magnitude of their cross product. If a and b are the vectors, then area equals to mod of a cross b. This calculation is useful in various geometric applications. Cross product and vector fields. In various calculus, the cross product is used to analyze vector fields. It helps in calculating quantities like circulation and flux in physics. Understanding how vector fields interact can lead to insights in electromagnetism and fluid dynamics. Cross product and vector fields. Now let us get to know about the relationship with dot product. The cross product is distinct from dot product, which produces a scalar. While the dot product measures how much two vectors align, the cross product measures their perpendicularity. Both products are essential tools in vector analysis, but they serve different purposes, whole different purposes, because dot product and cross product are completely different and have a whole different purposes when it comes to solving problems or doing calculations. Now let's know about cross product in computer graphics. In computer graphics, the cross product is used to calculate normals for surfaces. Normals are vital for lighting calculations and rendering 3D objects realistically. The correct orientation of normals affect how light interacts with surface. Now let's know about cross products in robotics. Robotics applications often use the cross product to determine joint, torques and forces. Understanding the mechanics of a robot arms involves analyzing the cross product of position and force vectors. This helps in designing robots that can perform complex tasks accurately. Now let's know about cross product and 3D rotations. The cross product is integral in representing and commuting rotations in 3D space. It helps define rotation axis and angles when using rotation matrices. This is crucial in simulations, animations and physical modeling. Common mistakes with cross product. A frequent error is confusing the cross product with the dot product. Remember that the cross product results in a vector while the dot product yields in a scalar. We need to always remember that cross product results in a vector, and while the dot product yields to a scalar. When you do the cross product of two vectors, you get a vector, honestly, not scalar. And when you do the dot product of two vectors, you get a scalar. Another mistake is neglecting the right hand rule when determining the direction of the result. Now let's know about few of the software implementations of cross product. Many programming languages and libraries include built-in functions for calculating the cross product. For instance, Python's py library provides an easy to use functions for this purpose. Leveraging these tools can simplify calculations and enhance productivity in coding. Now let's dig into some of the summary of key points. The cross product is a vector operation fundamental to physics and engineering. In math, it has distinct properties and applications from calculating torque to rendering graphics, and it is even implemented in some of the software applications, as we just read about. Understanding the cross product enriches comprehension of three-dimensional space and vector relationship. When you truly understand the deep meaning of cross product, it also enriches the comprehension of three-dimensional space and vector relationships. Thank you.